Harsh, welcome to YourPedia. Let's start your snap interview on the
Yes, sir.
subject electrical machines for your IOCL interview, right?
Yes, sir. I see.
Okay. Uh, Please give your brief introduction, Harsh.
Sir, myself, Harshoja. Sir, I belong to Faridabad, Haryana, and I did my B.Tech in electrical from JC Bose University, Faridabad, and I got graduated in 2022. And since then, I've taken a 1 year drop to prepare for GAIL.
Okay. So currently what you're doing, Harsh?
Sir, I'm right now, sir. I'm preparing for the examination, sir, GATE and other PSU exams.
Okay, fine. Yeah. See, why rotating magnetic field is not produced in a three-phase transformer?
Yes, sir.
Why rotating magnetic field is not produced in three-phase transformer?
Sir, in three-phase transformer, rotating magnetic field is not there. Sir, the reason?
Yeah, reason.
Reason, sir, because we need some, I mean to say, this, I mean to say, in case of a rotating machine, all the windings are arranged in a space angle of 120 degree, which is
Okay.
not always in the case of transformer, because we see transformer to be arranged in star or delta like that. So the spacing also matters, sir.
Fine. See, we are using synchronous generator for the purpose of power generation, right? In India, mostly.
Yes, sir.
Why we are not using induction generator or DC generator?
So DC generator, because sir, it will give us the DC power, but in all the industries we require the AC power for operation.
Okay.
And sir, synchronous generator and induction generator, basically we need the output to be at constant frequency, sir. So
Okay.
if we use a synchronous generator, the frequency will, if we move is, I mean to say, if we adjust the speed of the prime mover, so we can get the output at 50 hertz, because in India the frequency range, the frequency is 50 hertz everywhere.
Okay. But in windmills, where the wind power is not always fixed, we are going to use induction generator, right?
Sir, where?
In windmills, wind generating stations,
Yes, sir.
where wind power is not constant, this keep changing, right?
The speed will change, yes, sir.
There, which generator we are using?
Uh, sir, I have to look upon this, but I can guess here, sir.
Okay, please.
Sir, induction generator we can use, but the speed has to be adjusted. And if we use the synchronous generator, then we need a speed regulation system there, sir.
Okay. There is no any other way?
Sir, I can't recall any other way right now.
Okay. So any use of
If I
power
have to read
electronic converters when I'm using induction generator?
Sir, induction generators basically,
See, let me ask you this question. If I use induction generator, you are saying that frequency is not constant, right?
Yes, sir.
If frequency is not constant, what is the problem you are facing?
Sir, suppose in case of we have to supply the output power to a grid which operates at a constant frequency. So we have to match the frequency also, sir. So
If
without
frequency is
matching
not matching, what happens?
the frequency is not matching, then then the synchronization will not happen, and the power flow and the power system will become unstable.
What does it
And
mean by unstable?
unstable means the rotor of the synchronous generator or it will oscillate from a stable position, and the speed will
what is the consequences of unstable power system network?
The consequences of unstable power system in the network is that one I can recall is the basic consequence is that the rotor of the generator will move or oscillate about the stable position, and once it reaches, I mean to say, about the equilibrium position, and if it reaches to the unstable point, then it will move out of the stable zone, and it will also damage the, the rotor also, and the system will not supply the power as per the need.
Fine.
As per the need.
Okay. Well, let me go for the next question. See, we have a salient pole and cylindrical rotor synchronous machines, right?
Sir.
Where I can use a salient pole, where I can use cylindrical?
Sir, cylindrical, sir, first of all, salient pole, if I come to, it has a lesser mechanical stability. Salient pole. So we can use it where the speed is not very large. Suppose in hydropower plant, if the speed is not so large, we can use salient pole. And in case of a cylindrical rotor, we can use it where the speed is large. Suppose if the speed is large in case of a steam turbine, so we can use it in case of a steam turbine in the thermal plants.
Okay. So as per your answer, why to go for salient? Always you go for cylindrical only. What is the disadvantage if I go always for cylindrical? Then there is no need of salient, right?
Yeah, sir. Salient pole gives us the higher amount of power, sir, because there the reluctance power is also involved, so the power will increase.
See, assume that both the machines are designed for same power.
Okay,
I have
sir.
A cylindrical rotor synchronous generator of 15 megawatts and salient pole of 15 megawatt. Now, if that is the case, then always I can go for cylindrical. Then there is no need of creating salient pole machine, right?
Sir,
Any special advantage of salient pole? Can you?
So special advantage. I mean to say, sir, in case of salient pole, there is reluctance power also.
Okay, that is one point. Fine. That reluctance power. See, what is the stability angle in terms of stability angle? Which machine is more stable, cylindrical or this salient pole?
Sir, in terms of mechanical stability, the cylindrical is more stable.
Then all the advantages you are getting with cylindrical only, na?
Yeah, sir.
Then why? What is the purpose of salient pole?
Sir, then we have to look upon the design of both of them. Sir, I think I can make a guess here, sir, that the design of a cylindrical pole rotor can cost more money as compared to the salient pole. That can be a reason. I'm making a guess. I'm not sure right now, sir.
Okay, fine. Yeah. See, there is one induction motor, three-phase induction motor, which is running. Right?
Sir.
Now, all of a sudden, one of the phase got disconnected. Among RYB phases, suppose say phase B got disconnected. Now, what is the fate of the motor? Does the motor will run or it will stop? Or if we want to, if we want that motor to run continuously, then what we have to do? We have to reduce the load, or we can keep the same load, or it is not going to run at all. Whatever you do.
Sir, basically, if one phase is disconnected, and then it will operate as a single phase motor.
If one phase disconnected, it will become two-phase induction motor. Now, why it will become single phase?
So for two phases, sir, for two phase, the angle must be 90 degree.
Must be 90, or other than any angle it is possible?
No, sir, it has to be 90. It has to be 90. Yes, sir.
Okay. Say why it has to be 90?
Basically, sir, as per the design, it is 90 degree.
Okay. Fine, let me give you feedback, Mr. Harsh Oja.
Yes, sir.
Okay, you have basics of the concept, but look into it carefully. Then, see, you are guessing at some places, that's okay, accepted. But little you try to think indeed. Okay. First question I asked was this: why no RMF? Your answer was correct. That is, physical displacement of 120 degrees is also needed for the production of rotating magnetic field, along with the time displacement of 120, right?
Yes, sir.
That is the first question. Why not induction generator? See, your answer is correct, but I extended the question, like what happens if it is unstable and all. See, if the frequencies, if speed is not constant, frequency is not constant. If frequency is not constant, voltage magnitude is also not constant. Nah? See, E is equal to 4.445 FT. If the voltage magnitude is changing, you are connecting that generator to the grid. There is a voltage magnitude difference between the grid and your machine. Then circulating currents will flow. Your machine will damage.
Damage. Yes, sir.
See,
That
for parallel operation is not possible with induction generator, right?
okay, sir. Got it.
But with power electronic converters, you can change the frequency, you can change the magnitude of the voltage also. How it is, I'll tell you. Induction generator generates AC. Convert that AC to DC first. Then convert that DC to AC to your required frequency to the required magnitude of voltage.
Okay, sir. First of all, we have to change the AC to a DC. Then we can use inverter.
Yeah, DC to AC of your required frequency of required magnitude of voltage. You may ask, sir, why can't we use cycloconverters? Cycloconverter generates lots of harmonics. Cycloconverters.
Cycloconverter, there are harmonics.
Yeah, cycloconverters will generate lots of harmonics.
Okay, sir.
That's why we are going for, see, what is a cycloconverter which can change frequency from one frequency to another frequency, na?
Yes, sir. Yes, sir.
The problem with the induction generator is frequency, right?
Yes, sir.
With cycloconverters, I can change the frequency, but cycloconverters are practically not feasible due to economic reason and technical reasons. I go for AC, DC, AC, means AC to DC, DC to AC.
AC.
Right? See, in the generating stations where speed is not constant, definitely I have to go for induction generator only. Otherwise, yes, you have to put one mechanical gear system. Whatever may be the input speed, output speed must be constant. Then you can use a synchronous generator, right?
Yes, sir.
That is also one of the possibility.
Yes, sir. But there has to be, sir, some speed regulator. Otherwise, it will be not possible.
Mechanical speed regulator.
Yes, sir.
Right?
Yes, sir.
Yeah. So after that, okay. If it is unstable, you are explaining theoretical consequences what you studied in the book for the GATE examination.
Yes, sir.
If it is unstable, firstly, that machine will be disconnected from the grid.
Sir, can you repeat, sir?
If a particular machine is unstable, that machine will be disconnected from grid.
Grid, yes, sir.
Why? Because there is a relay called reverse power relay that will recognize whether this machine is supplying power to the grid or it is taking from the grid, right?
Okay, sir.
If it is unstable, as you said, speed of the machine will increase, right? If the speed of the machine increases, frequency will increase, and it is going to cross the angle of that 180 degrees. After 180, synchronous generator starts behaving as synchronous motor. Power will be negative, na?
Yes, sir. Yes, sir.
P is equal to EV by X into sin delta. If delta is greater than 180, sin delta is going to be negative, then it is absorbing power. There is a relay called reverse power relay, which will recognize that reverse power flow from grid to machine. Then that machine will be disconnected from grid, in fact, right?
Okay, sir.
Then remaining part of the remaining machines will be overloaded. See, now 10 machines are there sharing load. One of the machine got disconnected due to this instability. Therefore, 9 machines has to share the total load. Like that, one machine will get overload and each machine will get disconnected. Now, to the entire grid, there is no power at all. Right?
Yes, sir.
This is called as grid failure.
Okay, sir. So basically, a grid failure will happen. I can explain it, but I have to read upon it more, sir. Grid failure ke baare mein thoda.
That is one thing. Salient and cylindrical. See, in low speed generating station, suppose if you go for hydropower, hydropower are lesser in speed when compared to this, I can say like thermal power plant. Nah?
Yes, sir.
Now, if speed is less, if you want to maintain same frequency, F is equal to Pn by 120, I have to go for more number of poles, right?
Number of poles, yeah, sir.
On cylindrical, getting more number of poles, somewhat it is difficult. With salient, it is easy. Why? Because we are putting the poles outside, projected poles. Salient pole machine is also called as projected pole machine, right?
Machines, yes, sir.
So I can put any number of poles on salient pole, whereas in cylindrical, it is somewhat difficult to get for more number of poles. This is the advantage of salient pole machine when compared to cylindrical rotor machine, right?
Yes, sir.
See, if one of the phase of the induction motor disconnects, then the motor will rotate, but we have to reduce the load. How the motor will rotate, you may ask. See, there will be some rotating magnetic field, but the rotating magnetic field is not maximum. If you are going for 3 phases with 120 degrees apart, then the rotating magnetic field could usually is the maximum one. 1.5 times of N into I, right?
Sir, 1.5 times 5M.
5M, right?
Yes, sir.
But 5M. But if you are going with 2 phases other than 90 degrees, you won't get to 1.5 times. It will be less when compared to 1.5. But there is still some rotating magnetic field. we have to reduce the load on the machine, right?
Yes.
So this is the feedback. When
Self-taught.
you are thinking, have the thought clarity, not only the statements what you read from the book. Okay.
Okay.